Hello everybody, welcome back, and in this video we are going to learn about earthquakes. And this picture right here is a picture from Nepal in 2015 when this region was struck by a major earthquake that had about 7.6 magnitude. It was definitely one of the most devastating earthquakes that have been recorded within the last decade or so. Okay. Um, this is the definition of earthquakes. Earthquakes is just vibrations that are happening on the surface of the earth that was caused by the sudden breaking of rocks within the lithosphere. And they were also often produced by the rapid release of energy along a feature that is called a fault. Okay. This is an example of a fault right here, illustrated by these black lines that go from the surface all the way to the deeper parts of the earth. And along this fault right here, there will be a point where earthquakes are generated. Okay. And when earthquakes are generated from this point, it will also generate what we call as seismic waves. And these seismic waves will travel from this focus point right here all the way to the surface as well as to the inside of the earth. And the ones that goes to the surface and travel along the surface, these vibrations are the ones that we feel, that human feel on the surface. And that's something that we call as the earthquakes. Okay. And before we go on and discuss earthquakes in more detail, there are several terms that I would like to introduce you to. The first one is the focus point. The focus point is really just the the exact point where earthquakes are generated from, and it's typically located along a fault. So this is a fault, and this is the focus point right there, and then it is usually located at depth. Okay. And then another term that I would like to introduce you to is what we call as the epicenter. So if you take the focus point and you project it vertically upward, and when it intersects the surface, that is what we call as the epicenter. Okay, is the point on surface above the focus point. And then last but not least, we also have a fault slip. This term gives you how much you know how far how far the faults travel during earthquakes. Okay, and it's basically measured from this point to that point, and this is also a fault scarp, basically just an exposed part of the earth. In order to better understand how earthquakes are generated, we need to learn about the elastic rebound theory. What this theory tells us is that the tectonic forces slowly deform rocks until the forces holding the rocks together are overcome, and then it causes the stored energy to be violently released, right, as seismic waves, and those seismic waves are the ones that we call earthquakes. Okay, typically the ones that seismic waves that are traveling above, right on the surface of the earth, that's what we call as earthquakes. All right, so for example, if you pick up a twig outside and then you try to bend the twig, right, you try to break the twig, you apply forces first. Okay, and these forces will eventually overcome the strength of the twig, and then it will snap. And when it snaps, you typically can feel some vibrations on your hand, and that's basically the analogy for earthquakes. So all rocks are under pressure, and in some areas rocks are under lots of stress, and this stress can eventually overcome the strength of the rocks and cause vibrations during earthquakes. Okay, these are some other illustrations that gives you some insights on how faulting and earthquakes happen. So for example, in this example, we have two blocks. Block A wants to go to the left here, and block B wants to go to the right. So they're basically moving past each other horizontally, and then we also have a marker here on the surface, this red marker on the surface, and the fault will happen along this dashed line right here. Okay, so again, the block here, the block A started to move to the left, and block B started to move to the right here. And as you can see here, the markers start to bend, and then eventually it will snap along a fault, which is illustrated by this green surface right here at depth. And it generates earthquakes right at this focus point right here. Okay. And the distance between the two adjacent points along the marker is basically the amount of slip that we have on that fault. This is an example of how faulting and earthquakes occur. In 1906, we had a major earthquake in San Francisco, and this earthquake caused this fence to be offset. Okay, so again, this will be the fault slip. Okay, basically the distance of the displacements or offset of the fault. That is the fault trace right there. And that is again the fault slip at about 2.5 meter that happened in 1906. All right, this is an example of a fault scarp in Landers that generated an earthquake at about 7.3 magnitude in 1992. And here you can see this is basically the fault right here, and there's an exposed part of the fault which is called the fault scarp. So again, this is another example of the same fault scarp in a better view. All right, another earthquake terms that I would like to introduce you to is called the foreshocks and aftershocks. Okay, so foreshocks are earthquakes that happen before a main shock. Okay, here the main shock is illustrated by this magnitude 9.0 earthquake that happened in Tohoku in 2011. So there are some earthquakes that happen before that major earthquake, but look at this, there are a lot more earthquakes that happen after the main shock, and this would be called the aftershocks. As you can see here, the number of aftershocks are a lot more than foreshocks. Okay, so those are several things that I'd like to introduce you to, and I'm going to see you again on the next video. All right, bye bye for now.